back to Radical Learning. Today we're going to be doing Regents review, and we're going to be going over the Algebra 1 Common Core June 2014 Regents. So here are the answers to the multiple choice portion of the exam. So let's get started. Number 1 asks, when solving this equation, Emily wrote her first step as this equation, and what property does this use? So, to get from here to here, this is what she did. She added 9 to this side and 9 to this side to get this. So, that would be the addition property of equality because she added 9 to this side and 9 to this side. The commutative property means that the numbers can be moved around. Multiplication would obviously be multiplication, and distributive would be like this. 4 times 3x squared and 4 times 2. And those, she did not do either of those. So the answer is 1. Addition property of equality. Number 2 says that officials in a town used function C to analyze traffic patterns. It represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. The question asks, what would be the most appropriate domain for the function? So this is talking about cars, and right away you can tell that there shouldn't be any negatives because you can't have a negative number of cars. You also cannot have fractions. So no negatives and no fractions, which only leaves number 4, which is the answer. Number 3 asks what A minus B equals, and it tells you what A is and what B equals. So it tells us that A is 3x squared plus 5x minus 6, and it says minus B. So that means everything that is in B will have to be the opposite sign. So positives would be negative because you're subtracting, and negatives would be positive because subtracting a negative is actually adding. So B is negative 2x squared, so that would be plus 2x squared, and negative 6x, so that would be plus 6x, and plus 7. But we're subtracting, so it'd be minus 7. So A minus B is equal to this right here. But you can simplify that. You can add or subtract like terms. So 3x squared plus 2x squared is 5x squared. 5x plus 6x is 11x. And negative 6 minus 7 is negative 13. And this is answer number 2. Number 4 says, given these two inequalities, which graph is the solution? So, right away we see that right here and right here, this would be a solid line because it's also equal to, and this would be a dashed line. So, right away number 1 is out and number 3 is out because they have 2 solid lines. So, this equation, y plus x is greater than 2, we will turn it into the y equals mx plus b format. So, minus x on this side, so y is greater than negative x plus 2. So now we would, if we were making the graph, we would graph both these equations. So, this one starts, the y-intercept is at plus 2, positive 2. So that would be here, and it would be here on this graph. They both have lines at positive 2, and then it just decreases each x value by 1. So that's right. And the next equation has a y-intercept at negative 2. Which would be here. And and they both have that also. And it goes up by 3x, so 3 each time. So that's right. Now, these are shaded different ways. And so, y is greater than negative x plus 2. So, more than would be shading this way. And on this graph, it's shaded this way. So, number 2 is right. And we can check by saying y is less than 3x minus 2. And it's saying y is less than. So less than for y would be going this way, which is number 2. So the answer is number 2. So number 5 is saying which value of x satisfies the equation this. So it's really asking what x is equal to. So we're going to start off by distributing these 7/3 to the rest. So 7/3 times x is 7/3 of x. And 7/3 times 9 over 28 is equal to 63 over 84 is equal to 20. And next, you subtract this from this side. So 7/3 x is equal to... Okay, so for 6, it tells us these data points, and it says what type of function best models the given data. So we plug these into our calculator and we get a model like this. So I'll draw that for you. So like this. So we know that's exponential, so it can't be 1 or 2 linear, because linear goes like this, exponential goes like this, and this is exponential. And since it's going this way, that means it's growth, so it's number 4. Decay, an exponential decay goes like this, so it has to be the growth. This one says that a company that manufactures radios first pays its startup cost and then spends a certain amount of money to manufacture each radio. And R represents radios, and this is the equation they give you. So it's asking what the 5.25 stands for. So we know that it says it charges a startup cost, and startup costs are only paid once. So that would be this value right here, because it's only on there once and it doesn't depend on the amount of radios. And then it says it spends a certain amount of money to manufacture each radio. And 5.25 is multiplied by R because this is the coefficient. So that means it depends on each radio. And it says spends a certain amount of money on each radio. So the answer, 5.25, represents the amount of money spent to manufacture each radio, which is number 3. So number 8 asks which equation has the same solution as this. And to find that, we must find the solution to this. So we know that this is not factorable by using the diamond method, because nothing adds up to -6 and multiplies to 12. That's a whole number, so we cannot use that. We must use the quadratic formula, which is on your reference sheet. So -b plus or minus the square root of b squared minus 4ac over 2a. So we have to use this. This is a, b, and c. So a is 1, b is -6, and c is -12. So -6 plus or minus square root of -6 squared minus 4, 1 times -12 all over 2 times 1. So positive 6 plus or minus the square root of 36 minus 4 times negative 12, because 1 times negative 12 is just negative 12. So that would be minus negative 48 all over 2. So 6 plus or minus the square root of, this would be plus because subtracting a negative is actually adding. So 36 plus 48. So 84 over 2. So the answer is 6 over 2, which is actually just 3, plus or minus the square root of 84 over 2. Now, since we got the answer for this equation up here, we can plug that in, this answer, to x on these ones to see which one works, and it ends up being number 2. Number 9 says that a ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. And the question asks, for which interval is the ball's height always decreasing? So decreasing means going down, and that would be this way, which this is. And it starts decreasing at the point right here, which is 2.5. So, and it asks when it's always decreasing. So it has to be, x has to be greater than 2.5. But after it's hit the ground, it cannot go any farther. So it has to be more than 5.5, or less than 5.5. So x is less than 5.5, which is number 3. So number 10 asks, what are the roots of this equation here? So to find the roots, we can use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. So we know that this right here is a, so a equals 1, b equals 4, and c equals negative 16. So we plug that into this formula. X equals negative 4 plus or minus the square root of 4 squared minus 4, 1 times negative 16, all over 2 times 1. So negative 4 plus or minus the square root of 4 squared, which is 16, minus negative 4 times, or minus 4 times negative 16, which would be 64 over 2. So negative 4 plus or minus the square root of, it's going to be a negative number, so negative 48 over 2. So negative 4 divided by 2 equals negative 2. This negative 48, the square root of negative 48 over 2 is simplified to 2 square roots of 5, which is number 2. So number 11 asks what the correlation coefficient is on this line right here. So in order to find that the easiest, you can plug it into your calculator like this. You plot all the points, then you press menu and press analyze, which is option number 4. And then you can press number 6, which is regression. And it is asking for the linear regression. So we click that, and it tells us right there. So we press analyze, we press escape, and you can see that's the line. So now we add a page. Add. Oh. We can go back and do listen spreadsheets, or we can just use the first page here. Now we press menu, statistics, stat calculations, and linear regression. My X list would be the X, my Y list would be the Y, and we can press OK. And it says our R value is minus 0.927, which is actually, if we round to the nearest hundredth like it asks, it'd be negative 0.93, which is option number 3. 12 says that Keith determines the zeros of the function f of x to be negative 6 and 5. What could Keith's functions be? And we know, so negative 5 and 5, we know that these numbers must add up to 0 on one of the parts. So negative 6, let's take first. So negative 6 and positive 6 do add up to 0. So one part has to be x plus 6. So that leaves us with number 1 and number 3. And 5, let's take that one next. 5 plus 5 is equal 10 to 10, not 0. But x minus 5 is equal to 0. So x minus 5. And the only answer with both of these is number 3, which is your answer. Number 13 asks, which expression results in a rational number? So we know rational means ending. So the square root of the square root of 2 is not an ending number. It is (1.14142113), and it keeps going on. 3 square roots of 3 is equal, I'll write this down here, 5.196152, and it keeps going on. But the square root of 16 is equal to 4, and the square root of 9 is 3. And so n plus p would be the rational one, which is number 3, because 3 plus 4 is equal to 7, and that's rational. Which system of equation has the same solution as the system below? So this is the one that we were looking at. And first, before we solve anything, we can look for some patterns. So this one, 2x plus 2y equals 16 is the same thing. So number 1 could be an option. X plus y equals 16 is not the same thing as this, because this is, the x and y are split in half, but this number stays the same, so it cannot be 3. And 2 also has the same thing, so it can be 2. It also could be 4, because it's multiplied by 3. Now, we can look at the second part. 3x minus y equals 4. So, in number 1, everything is, the x and y are doubled, but the number on the outside is not doubled. So it cannot be number 1. Number 2, everything is doubled, so it can be 2. And the answer is 2. But we should check 4 anyway. The numbers are doubled, but the sign is not the same, so it cannot be 4 either. So your answer is number 2. Number 15 asks which equation represents this table. So we know right away that this can't be linear, so we can cross out numbers 2 and 3. It can't be linear because it does not go up evenly each time. Even though this skips right here, it still doesn't go evenly because 65 to 129 is 64, and 129 to 257 is 128, so that can't be right. So it obviously has to be exponential. So we can plot these points, and it turns out like this, and that is exponential. Now we can go to Menu, Analyze, Regression, and Show Exponential, and it tells us what it is. And then you can round these numbers to get the equation. So 1 times 1.9, which rounds up to 2 to the x. So that would be number 3. 2x, 2 to the x plus 1. He has 4 more nickels than dimes in his pocket in number 16. For a total of $1.25, which equation could be used to determine the numbers of dimes in his pocket. Dimes is x, so dimes equals x. And it says that John has 4 more nickels than dimes. So nickels would be x plus 4 because he has 4 more. And we know that a dime is worth 0.10 cents. Or $0.10, so 10 cents, and nickels are worth 5 cents, which is 0.05. And now we just have to put that together. So dimes is 0.10 times x plus his nickels, which is 0.05 times x plus 4, is equal to his total amount, $1.25. And that would be number 2. Number 17 asks which statement is always true. It says that the first one, that f of x is always going to be below 0, which is wrong because if you plug 1 in, then it's above. Number 2 says it's always going to be greater than 0, which is also wrong, because you can plug in negative numbers and get less than 0. That also explains number 3. So the only left one is number 4. Because if this is always above 1, meaning it's positive, then the answer is always going to be positive also, and above 1. Or above 0. So it could even be a fraction. So the answer is number 4. Number 18 asks, during which interval was their average speed the greatest? The greatest would be the one that points up most this way. So, for example, this would be greater than a line like this. So, which line is most like this? We want to find out. This one's pretty good. This line is more this way, so it cannot be number 2. Number 3, the 6th hour to the 8th. This is pretty this way, but it's over 2 hours. So it is not more than the first one. And then the 4th one, this to this, is pretty horizontal. So it's not that one either. So it has to be number 1. So number 19, it asks us about these test scores and how they're related. And you would go through and prove each one of these is either true or false. So I'm going to prove to you why number 3 is right. The mean is the average. So semester 1, we want to see all these. So 70 plus 91 plus 88 plus 83 plus 94 over 5. So the mean is 86.8. Semester 2, 91 plus 96 plus 80 plus 77 plus 88 plus 85 plus 92 all over 7 is equal to 87. So the mean is 87. And that is more than that. So semester 2, is greater than semester 1. So number 20 asks which point could be used to find f of 2. And that would be point A because it is the x-intercept. So the answer is 1A. So number 21 asks which equations can be used to determine the prompt. Okay, so the sunflower is 3 inches at the beginning, so in form y equals mx plus b form. If it's 3 inches already, that would be b. And it grows 2 inches every week, so the coefficient would be 2. So y equals 2x plus 3. So, but they use, instead of y, they use f of n, which is the same thing. Which is number 1. So number 1 is definitely one of them. So it cannot be number 2, and it also can't be 3, because 1 works. So now, we have to choose whether 2 works or 3 works. And it does not say that, in number 2, that it is 3 inches to start with. So it definitely cannot be number 1, because Roman numeral 2 does not work. And Roman numeral number 3 does work, because it says where f of 0 equals 3. So at 0, the sunflower is 3 inches, which is true. So it's number 4, Roman numerals 1 and 3. Number 22 asks which equation can be used to determine the monthly bill. So, it is $60 per month, and that's a set cost. So that would be our b in the equation if we're using y equals mx plus b format, which we are. So that would be plus 60. So we know it's c equals because we want to find the cost of the monthly bill, and that's what c represents. So now it's asking the cost of the additional data is this right here. So per megabyte, which is D, so 0.05 D, and there's your equation, which is number 4. So number 23 asks for us to express this equation in terms of R, which is basically just solving for R. So first what I'm going to do is divide this side by pi times height. So V over pi times height equals 1/3 R squared. So now we have to get R alone. In order to do that, we have to get rid of this 1/3. So dividing by a fraction is actually multiplying by its reciprocal. So V over pi times h times 3 over 1 is equal to 3v over pi times h. Let's draw on there. So 3v over pi times h is equal to r squared, and we want r by itself, not squared, so we have to square root it. So r equals 3v over the square, or pi times h, the square root of that. So this is our answer, which is answer number 1. So number 24 asks which formula can determine the number of squares, shaded squares. And it gives you term 1, term 2, and term 3. we see that each time it adds 4 more in the corners. So 1 in each corner, so that's 4 more per number. So 4n. Now we gotta find out what the plus b is. So we look at number 1, and we know that 1 times 4 is 4. But there's still 8. So it actually starts off with 8. So it's 4n plus 8, not 4. Because in term 1, there's 4, 5, 6, 7, 8, 9, 10, 11, 12. So it includes these 8. So a of n is equal to 4n plus 8, which is number 2. Thanks for watching!